In the previous example, the inverse function that we were seeking happened to be the reciprocal of the inverse function we needed to use. Let's look at a case where the inverse function we are seeking is not the same as the inverse function we need to use. So let's look at the example, the inverse cotangent of 1/2. Okay, for the inverse cotangent we will use the inverse cosine. Okay, the cosine and cotangent are not reciprocal functions. Okay, so to solve this, we're going to draw the coordinate plane, and we will remember all students take calculus. Okay, the cotangent is positive in the first and third quadrants. Okay, but we're going to use the inverse cosine. The inverse cosine limits us to the first and the second quadrant. The inverse cosine is positive in the first quadrant and negative in the second quadrant. Therefore, our triangle is going to be drawn in the first quadrant. So, I will draw our triangle. Okay, the definition of cotangent is adjacent over hypotenuse, adjacent over opposite. So the adjacent is 1 and the opposite is 2. Now, we're going to use the Pythagorean theorem to find the length of our hypotenuse. So we have x squared plus y squared equals the hypotenuse squared. So 1 plus 4 equals the hypotenuse squared. 5 equals the hypotenuse squared. So the hypotenuse is the square root of 5. Okay, now the inverse cotangent of 1/2 is going to be the same as the inverse cosine of 1 over the square root of 5, which is adjacent over hypotenuse. Okay, so now we use our calculator, making sure it's in radian mode. Hit the second, cosine, enter 1 over square root of 5, and that gives us approximately 1.11. So the inverse cotangent of 1/2 is equivalent to the inverse cosine of 1 over the square root of 5, which is approximately 1.11.